This is the first mini lecture for section 3.4 of the syllabus that corresponds mainly to section 3.3 of the textbook. We're going to talk about algorithms for multiplication in this mini lecture. So we have several ways of representing the base 10 multiplication algorithm. We can use math strips and units, place value cards, expanded notation, and the partial products algorithm. These are used to represent the work performed in the final algorithm. As usual, when illustrating math strips and units, we'll use a square for a mat, a stick for a strip, and a dot for a unit. So let's illustrate the product of 3 and 143 using math strips and units. Well, it's 3 143s. That's how I interpret that product. So I'm just going to draw 3 copies of 143. Okay, step 1, we just add them together. So remember, multiplication is repeated addition. So we end up with 3 mats. Twelve strips. And 9 units. And then we need to make exchanges. Well, we don't have any problem with the units because there's 9 of them. The strips are a problem because there's 12. Remember, we're only allowed to have up to 9 of anything. So I'm going to take 10 of these strips and exchange them for a single mat. So now I have 4 mats. Two strips, and 9 units. So again, we view multiplication as repeated addition. You just make the 3 groups, you add them, and then you make exchanges. As usual, it's the intermediate steps that are really important to show carefully. Okay, so now let's try illustrating 3 times 145 using place value cards. And I just worked 143. This is 145. Note that changed. That's actually a mistake, but we'll just go with it because this will involve more exchanges. So I think it'll be a better illustration. Yeah, so we start with our 3 groups of 145. So we have 300s. Sorry, rather 100. 4 10s, 5 1s, and we have 3 groups of those. So again, we're just viewing this as repeated addition. we put them all together. We have our 300s, 3 times 4 tens, and 3 times 5 ones. Okay, then we make exchanges. So we have too many ones. So we're going to exchange 10 of those ones for a 10. Okay, so we'll still have our 300s. And then we have our 12 tens plus an extra one, or 13 in all. Okay, so there's the 13th one. And that leaves us with 5 ones. Okay, now I've got too many 10s, so I'm going to exchange 10 of them for 100. So that leaves us with 400s now. Or 3 10s and 5 ones. Okay, so let's recall how we would do this in the final algorithm. What you were taught in grade school. We have 3 times 145. We'd write like that. And 3 times 5 is 15. So what I do is I write down the 5, put the little 1 up there. What does that mean? That means I took my 15 ones, I exchanged 10 of the ones for 1 10. So this little 1 here is this one right here. And then I do 3 times 4 plus 1 is 13. Okay, so that was 3 times 4 tens is 12 tens, plus 1 10 is 13 tens. So I have 3 tens that I write down there, and then I exchange 10 tens for 100. So this one right here is this 100 right here. And then 3 times 1 plus 1 is 4. Okay, so what's important here is to really be able to explain how these two numbers here correspond to the moves that we made here. It's the exact same steps. This is just a really compact way of doing the same thing. Okay, so now let's illustrate 143. 3 times 143 using expanded notation. So we're back to that original example. So it's 3 times 100 plus 40 plus 3 is 300. 3 times 40 is 120. 3 times 3 is 9. And I just add those up. 300 plus 120 plus 9 is 429. So this is using expanded notation. What's good about it is that it allows you to see how we're doing 3 simple products and then just adding them. The drawback is that it's written horizontally, so it's not really set up to add easily. The partial product algorithm actually does the same thing, but it lines things up vertically so that they're easier to add. So we have 143 times 3. 3 times 3 is 9. 3 times 40 is 120. 3 times 100 is 300. I add those up, and there's our answer. So it's the same thing I did up here, but it's lined up vertically. And the final algorithm, let me also write that for 143 times 3. I've got 3 times 3 is 9. 3 times 4 tens is 12 tens. So I put 2 tens down there, and I exchange 10 tens for 100. And 3 times 1 plus 1 is 4. That's 4 hundredths. So you can see this little 1 right here represents the 10 tens that I exchanged for 100.